Welcome, everyone, to today's Explainer on Requirements Engineering. We're diving straight into Chapter 4, Section 1 of the textbook, focusing on functional and non-functional requirements. I always like to kick this topic off by emphasizing one simple truth. Requirements are the absolute foundation of any system. They represent the actual needs of the customer, whether you're building software to control a medical device, process online orders, or just find some information. If you don't get this foundational step right, literally nothing else matters. So grab your notes, get comfortable, and let's jump in. All right, here is a quick look at our roadmap for today. We'll start with an introduction, move into defining functional requirements, discuss completeness and consistency, explore non-functional requirements and types, look at metrics and requirement conflicts, and finally wrap up with a lecture summary and key facts. Before we start throwing technical definitions around, I want you to picture a very real scenario. What happens if your code is perfect, but your requirements are wrong? Really think about it. You could write the most elegant, beautifully architected bug-free software in the world, but if it doesn't do what the customer actually needs it to do, the system is a complete failure. Software engineering isn't just about writing great code, it's about solving the right problem. If the requirements are off, no amount of brilliant programming is going to save your project. Okay, let's transition right into Section 1, defining functional requirements. So what exactly is a functional requirement? Formally, these are statements of services the system should provide, how the system should react to particular inputs, and its expected behaviors in specific situations. But in plain English, this just means what the system should do. If a user clicks a submit button, what happens next? What exact data does the system spit out? What services does it offer? And hey, sometimes functional requirements might even explicitly state what a system should not do. Let's ground this with an example. We'll use the textbook's MentCare system, which is a patient information system for mental health care. Here are two functional requirements taken straight from the text. First, a user shall be able to search the appointments lists for all clinics. Second, the system shall generate each day, for each clinic, a list of patients who are expected to attend appointments that day. Notice how clear these features are? They describe exact actions and outputs that the medical staff need for their day-to-day routines. But hold on, because there is a massive trap hiding right here, and we call it the ambiguity problem. Think back to that first requirement. What exactly does the word search actually mean? A doctor might expect search to mean typing in a patient's name and having the system instantly scan every single clinic simultaneously. Why? Because mental health patients can sometimes get confused and show up at the wrong clinic. But a developer? They might read that exact same sentence and build a system where you have to select a specific clinic from a drop-down menu first and only then search within it. It uses less processing power, so to them it makes total sense. And boom, this is exactly how disputes start. Ambiguity leads developers to build something the customer never wanted, which means delays, frustration, and wasted money. To avoid those messy disputes, our requirements really need to be complete and consistent. Completeness means all required services and information are defined, no missing pieces. Consistency means none of the requirements contradict each other. Now, definitely flag this for your exams. Achieving total completeness and consistency in a large system is almost impossible. There's just no way around it. Large projects have dozens of stakeholders with totally different needs, and, well, humans make mistakes. You'll inevitably find inconsistencies way later during development. So just remember, while functional requirements define what a system does, getting them 100% complete and consistent is incredibly tough. All right, moving smoothly along to Section 2, non-functional requirements and types. This brings us to non-functional requirements, or NFRs. If functional requirements are the what, the non-functional requirements are the how. These are constraints on the services or functions offered by the system, and rather than being about one specific feature, they usually apply to the system as a whole. We're talking about how well, how fast, or how securely the system must operate. You can't just click a button for these. They are the overarching rules, like timing constraints, development standards, or privacy laws that dictate the whole architecture. Now, it's pretty easy to assume that the shiny features are the most important part of a project. But actually, non-functional requirements are often way more critical. Think about it. If a system is missing a specific feature, users can usually find a clever workaround. But what if a medical system crashes completely because it couldn't handle the user load? The whole thing is entirely useless. As the textbook points out, if an aircraft control system fails its reliability requirements, it simply won't be certified to fly. End of story. If an embedded system misses its performance timing, the control functions fail, and the results could be catastrophic. You literally cannot just work around a systemic failure. This hierarchy beautifully illustrates how non-functional requirements are broken down. As you can see, they branch out into three main categories: product requirements, organizational requirements, and external requirements. And from there, they subdivide even further into specific constraints like efficiency, dependability, security, and regulatory rules. Let's unpack each of these categories using the MintCare system to really anchor the concepts. First up, product requirements. These dictate the runtime behaviors of the software, things like speed, memory, and reliability. For MintCare, a product requirement might be that downtime during working hours cannot exceed 5 seconds in any given day. Next, we have organizational requirements. These come directly from company policies. So for MintCare, an organizational requirement dictates that users must log in using an authorized health authority identity card, not just a standard username and password. Finally, external requirements. These are driven by outside factors like safety regulators or government legislation. For MintCare, the system absolutely must strictly adhere to national patient privacy legislation. That leads us right into Section 3, Metrics and Requirement Conflicts. Here's a massive trap stakeholders fall into all the time, stating non-functional requirements as vague goals. You'll hear things like, the system should be easy to use. Well, that's a nice intention, but it is an absolute nightmare for a developer. Easy to use is totally subjective. It leaves way too much room for arguing later on. Instead, we have to convert that subjective goal into a testable, quantitative requirement using metrics. So instead of easy to use, we say, medical staff shall be able to use all system functions after 2 hours of training, and users shall make no more than 2 errors per hour. Boom. Now it's quantitative. We can objectively test that. This table lays out some excellent examples of exactly how we measure these non-functional requirements. If you want to measure speed, you don't just say, make it fast. You specify the exact processed transactions per second, or the exact screen refresh time. For robustness, you might measure the time to restart after failure. For portability, you look at the number of target systems. The golden rule here is to always aim to express your non-functional requirements quantitatively. Now here's the kicker. These non-functional requirements, they contradict each other all the time. Remember that organizational requirement for men's care where users need physical ID card readers for security? Well, what happens if the doctors also have a functional requirement that they need to access the system on their smartphones while walking the hospital wards? Smartphones definitely don't have health authority ID card readers attached to them. So suddenly, your strict security requirement is clashing directly with your mobility requirement. System architects have to find a compromise here, maybe designing a different, equally secure authentication method specifically for mobile devices. So, just to recap, non-functional requirements act as system-wide constraints that have to be measurable to be testable, and architects are constantly balancing them when they inevitably clash. And just like that, we're at Section 4, Lecture Summary and Key Facts. Let's wrap this all up. If you're studying for an upcoming assessment, this is your goldmine. Fact 1. Functional requirements equal features. They are the services, reactions, and expected behaviors of your system. Fact 2. Non-functional requirements equal constraints. These apply to the entire system and are broken down into product, organizational, and external categories. Fact 3. Even though we really want our requirements to be complete and consistent, achieving both is practically impossible in large systems because of human error and clashing stakeholder needs. And finally, Fact 4. Never leave non-functional requirements as vague goals. They absolutely must be converted into measurable metrics so they can be tested. Bottom line, both types of requirements need to be heavily documented early on, so you don't end up paying for incredibly expensive rework down the line. As we gear up for our next topic, requirements elicitation, I want to leave you with something to chew on. We now know exactly what functional and non-functional requirements are, but how do we actually extract these complex, often conflicting requirements out of human stakeholders who honestly might not even know what they want yet? That is a whole different puzzle to solve. Have a think about that, and I'll see you in our next explainer.